What is the law? This is the biological law. This is telling you if y represents the number of bunny rabbits, this is telling you how fast y represents the number of bunny rabbits. Okay, we'll keep it safe in this class. Y represents the number of bacteria. You want to talk about bunny rabbits multiplying in Georgia after all. Huh? Yeah, okay. So, what is this saying?
How fast the colony is growing?
Absolutely. How fast the colony is growing? How fast the colony is growing depends on how many you have. Right? That is the biological law. And your biology professor says, what Mr. Cole has? He's going to give me the function of time. Clear? Yes. So your biology professor says, you know, if I have 10 bunny rabbits, if I start with 10 bacteria. If I start with 10 bacteria, an hour later I'll have 20. Whereas if I started with 5 bacteria, an hour later I'd have 10. So it seems to me that the speed, or the rate of, how fast the population is growing, depends on how big the population is right now. How fast the population is growing is proportional. It could be that. It could be that. You'd have to ask your biology professor, but let's say it's that. How fast your population is growing depends on how big your population is at that instant. So you say to your biology professor, it seems to me like you are talking about an exponential situation. Huh? You say to your biology professor, hey, you don't know any math, okay. Your population is this. It's experiment. So, you can go and ask your biology professor, you can go and ask your chemistry professor, you can even go and ask your economics professor. They do also a little bit of math. That they have laws that dictate equations involving derivatives. And then they say to the mathematician, help me out here. Okay. And I can assure you that that is a huge problem. Okay? 95% of all mathematics research, you can quote me on this, 95% of all mathematical research is done on solving differential equations. And that is not an exaggeration. Most people, when they are doing mathematics, they ask, what are you doing? Well, I have this situation, and I'm like, you know, things are changing like this and like this, and I'm trying to find some quantity. So what field are you in? Economics. What field are you in? Biology. What field are you in? High-tech. Okay. Now, we all know that there's a constant proportionality. It could be 2. Now, this is telling me the speed at which the population is changing. And I want to know the population as a function of time. Clear? Now, in essence, what I'm going to have to do is some kind of integration. Because if you want to get rid of derivatives, you have to integrate. And when I integrate here, I'm going to pick up a constant. Which means to say that it's not enough to tell me the velocity. You have to tell me how things started. So they would tell you something like what Mr. Kovacs? Started with 17 bacteria. 17 bacteria was my initial condition. Mr. Kohlhaas? So that is the differential equation. That is your biology professor now. Saying, help me out. Which professor is telling you this? Anybody? For the Snickers bar, which professor is telling you that?
Physics professor.
Which physics professor? The nuclear physicist. Huh? Talking about radioactive particles. I got 10 atoms of plutonium. And they are disappearing. Why? Because they are decaying. How do they decay? Well, depending on how much you have. If you start with 100, you will next day you will have 50. And the hour after that, you'll have 25. And the hour after that, you'll have 12 and a half. Atoms, I don't know what that is, but this is Professor Lee, even talk about half atoms. Huh? So things decaying according to this law. Why do I know it's decaying? Because it's decreasing. The population is 10, it's decreasing at 30 per hour. If the population is 100, it's decreasing at negative 300 per hour. But then we'll have to say, well, I have initially something like 200. I have something like 200 grams. So this is your biology professor, this is your physics professor. So these are natural things because they observe, they follow laws of nature. They come from the laws of nature. Let us talk about how to solve this equation here. Now, you can go and ask your calculus 1 friend, how would you solve something like this? They would say to you, you're looking for something that differentiates to twice what it is. I would say e to the 2x. Yeah? You're looking for something that differentiates to negative 3 what it is. I would say e to the negative 3. What we call these variable separable equations. The simplest kind of differential equations. Absolutely the simplest. Variable separable. And by equations, I mean what kind of equations?
X.
Huh? Differential equations. Right?
Yeah.
All right. That's variable separable differential equations. Too many syllables there. Variable separable differential equations. Equations with the derivatives, but you can separate the variables. So let me give you this example here. So y by dt. What I do is we separate the variables. We take the dt's to the side and we take the y to the side. We have dy. dy by dt is equal to 2y. So let's take the thing with the y's here and the thing with t's on that side. What? Let's leave the 2 there. Well, this is not kosher. How do you make this kosher, Mr. Besser? Now it's kosher. What is this?
It's
ln
of y.
ln of y is equal to
2t. Wait.
2t?
No.
Yes?
Wait, it is.
Yes?
Oh, yeah.
Yes? Yes? Huh?
Plus C.
And that's your solution. Now you put your initial condition and you get your. Except, well, now, how do you get rid of the long?
Just eat that stuff.
Y is e to that stuff, correct? Very good. You have good pre-calculus, Professor. Mr. Collins. Y is e to the 2t plus c. Who had a good college algebra, Professor? This is what? E to the 2t times e to the c, which is a
Another constant.
constant. Let's call it a. Is that okay? Now I'll get my a by this initial condition here. Huh? What's my a? That's 17, huh? See, y of 0 is what? 17. But that's a e to the power.
0, 0.
What's a e to the power of 0?
A.
So a is